Hi everyone. I created this video to give people a general introduction to developing an analysis using R and RStudio, and so this is intended for people who are just starting out using R and RStudio. And what I'm going to do, because I thought the best way to teach it would be to actually have a very defined analysis that we're going to do, like a real world task. We're going to analyze some Scottish baby names. So I found this pretty cool website. It's from the National Records of Scotland, and it has the names of babies born in Scotland since 1974 up to 2015. So it has historical data about baby names. And I thought it'd be fun to actually have a look at trends in baby names, which names are becoming popular over time. And this video was made in 2016, so our incoming first year students will have been born around 1998. So what we're going to do is we're going to find the top 10 baby names from 1998, and we're going to look at the trends for those names over time. So I made this little hand-drawn sketch here to show what I want the final product to look like. So we'd have two little graphs, one for boys and one for girls. And then we're going to have on the horizontal axis, we'll have year of birth, 1974 to 2015. And on the vertical axis, some measure of popularity. For example, the number of boys that were given that name in that year. Okay, so that's kind of where we want to get to. And just so everyone knows, the analysis you're going to see today, I've never done this analysis before. I haven't worked with the data here before. This is all going to be live coding, so you're going to see how to develop an analysis, warts and all. So I hopefully don't make too many mistakes, and hopefully we can get to this stage where we actually have this as the final product. Okay, so let's launch RStudio. So first of all, I want to make the point that when you install R in RStudio, you're going to have two icons that you can click for, and these are two different ways of interacting with R. They're both what are called integrated development environments, IDEs for short, and these are ways of interacting with R. These are ways of developing an analysis. And the one that I'm going to be using and that I recommend that you use is RStudio. So hopefully you've downloaded R and you've downloaded RStudio. So you click on this icon for RStudio to launch the program. There's another one called RCommander, which is sort of an older IDE. It doesn't have the same kind of enhancements that RStudio has. I don't recommend using this. Okay, so if I launch RStudio, you'll see something that looks like this. Actually, let me launch it. Let me quit this and then relaunch it so you can see what it looks like when it first comes up. Okay, so this is just a fresh launch here of RStudio. There are different panes within this larger window. We have here the R console, and this is actually this is the R part of RStudio. So this is where the R language runs, and there's a command prompt here and a cursor blinking at us telling us to do something or to type something. This is where we can type in commands. We can play around with R and do different things. Over here, we have some other windows here. This one has two tabs. This has environment, which tells us what functions and objects have been defined in our current environment. I have a function that I created. You won't have this, which loads at startup. We can see the history of commands that we've typed. Apparently I have been doing a lot of things, making chickens talk and printing out hi. So for what that's worth. So this is the command history, things we've typed into the console. There are these other things which I never use. In fact, I'm not even entirely sure what they do. They're not that important. Down here we have a bunch of different tabs. We have Files tab, which shows us the files that are located in the current directory. Any plots we make will appear here, so our final plots will appear over here. Add-on packages. So So there's base R, right, which comes with certain sets of functions and things that you can do with it. But the great thing about R is that it is user extensible, so any user can actually create a package that adds additional functionality to R, and other people can use that package. So it's a great community-supported type of software. And you can install packages that add additional functionality. So if you look at your packages list, you can see any packages that have been installed. And it's a little worrying to me that I'm seeing duplicates of certain packages, but I'll deal with that later. It's not a big deal. Anyway, you can see which packages, add-on packages you have installed here. There's a help tab, right, which prints out help for different functions you might use. And then there's some viewer, which I don't know what the viewer actually does. I never really use it. So yeah, so let's play around a little bit with the R console. This is the R console here. Now, we can. The way this works is it's waiting for input right now. That's the command prompt. That little right pointing arrow is a command prompt. We can type in a command at that prompt, and what R will do is evaluate it. So let's just use R as a calculator. Let's see if R knows what 2 plus 2 is. So I'm just going to type 2 plus 2, and I'm going to press return. And you can see that R has read in this command that I typed. It's interpreted it. It realized I wanted to add 2 plus 2, and then it returned the result. And this little 1 here tells you that the result is actually a vector of length 1. And the first element of this vector is 4. Basically everything, or a lot of things in R, are stored as a vector. Okay, so we can actually do other things. We can multiply. 3 times 2 is 6. 3 times 2 plus 2 is 8, and so on. So that's basically how we interact with the console. Anytime you type in a command, it evaluates it, and it will print the result. Now we can also store values in variables. So let's say we wanted to store the result of a calculation in a variable called x. So we type x, then we type what's called the assignment operator, okay, which is it's a less than sign followed by a dash. We put a space between the x, the assignment operator, and another space between what's going to go on the right hand side, which will be 2. So now we've created a variable. Notice that R did not print anything out there. What it did was it took this value 2 and it stored it in the variable x. And you can see that that has appeared now up in our environment pane. You can see that we have a new thing in our session, a new object in our session called x with a value of 2. And if I want to print out the value of x, I just type x on a blank line and it prints out its value. Okay, so we can actually, sometimes it's convenient to split long commands over multiple lines. So we might want to say x equals 1 plus 3 plus 5 plus 7 plus, and if we press return here, notice that our command prompt has changed to this blue plus. When you see this blue plus, it means that R is waiting for you to finish the command you started typing previously. So it's waiting for us. Because we ended this line with a plus, it knows that that is not done yet. A plus has to have something on both sides of it, so we can keep adding values. Now, if we end this line, it's going to add all those together. You can see x has the value of 64. If we want to print it on the console, we just print x. And x is equal to 64. So you can break up commands over multiple lines in the console. Sometimes you might do something that you don't intend, like you want to store a string in R, so it can be, this is a very important message. And let's say, normally you'd store a string like that. So now x has the value, this is a very important message, enclosed in quotes. But let's say you forgot to type in the last quote and you press return. And then you think, hey, what's going on? Why isn't this working? I'm getting this plus over and over. Well, it's waiting for that end quote. But sometimes you might not be able to figure out what it is that you typed wrong. It may be an open bracket that you didn't close, maybe a quote that you didn't close or something like that. If you get to this stage, don't panic, just press the escape key. Okay, and that'll get you back to the command prompt and cancel what you were typing in the previous command. Another thing that's really useful to know about is you can actually retrieve previous commands in your command history using the up and down arrows on your keyboard. So if I press the up arrow, it gets me to the last thing I typed. If I press it again, it gets me to the thing I typed before. I can keep going up through my history to things I typed before. Okay, this can be very useful and can save you typing if you just want to access the last command you typed, change one thing, press return. Okay, so the up and down arrows are useful when you're playing around in the console. Okay, so the console, as I said, it does store the history of the commands that you've typed, right? These are all the commands that I've typed so far. But some of those commands, you know, I was just playing around, right? This isn't part of my analysis. None of this is actually intended to be part of my analysis. You can think of your console as like a sandbox where you try things out, you try various things out. You try to, you might have to tweak a command to get it to work properly. But you don't necessarily want to remember all those different tweaks that you've done. So what you do is you develop what's called an R script. So I'm going to open up an R script. I'm going to go to File, New File, R script. And this makes a new file here. Now, I can type things in here. I can develop my analysis. I can make x be, so this command makes x be a vector going from 1 to 5. Now, if I press return here, nothing happens, right? I'm not typing it in the console. I'm typing it in this text editor. Now, this text editor itself it's just a text editor. It doesn't really do anything. If I want to actually send this command to the console, I put the cursor on the line containing the command, and I hold down Control and press Enter. So Control Enter. Control plus Enter will send the command to the console. Now, this line I just typed here is a special kind of statement in a script. You can see that I started the line with this not pound sign, but it's, I guess we'll call it a hashtag. I started this line with a hashtag. If I start a line with a hashtag, that tells R that this is a comment and that R should ignore the rest of the line. So basically R will not, I can send this to the console, right? And R will not do anything with it. It'll just skip it. It knows not to interpret that line because it has a hashtag at the beginning. So comments can be useful for people reading your code. So it's useful to know how to make comments. Okay, let's see. What are we going to do next? As I said, this is now we'll start our analysis, right? As I mentioned before, this is live coding. None of this has been done before, so I actually haven't done this analysis. So let's see what we can do. Don't worry if you don't understand all the details of what I'm doing. The important thing is to basically understand how to interact with RStudio. That's really what I want to teach you here. Okay, so where do we begin? We need to get the data. So I found a link to a data file here. It's a CSV file. CSV stands for comma-separated values. That's the format of this file. It's basically a text file where the values are separated by commas. And I found the link to this file, and what I'm going to do is I'm going to download it. So I'm just going to click on that link. It's going to download that file. And I was going to put it in my downloads folder. So I will open up my file browser. I'm going to go to my downloads folder. Okay. Oops. All right. There in my downloads folder is the CSV file. It's a text file, right? and it has this name, baby's first names, all years.csv. Now I'm going to put that file somewhere else. Whenever you start an analysis, I'm going to go to a directory, let's see. I made this directory called my_r_stuff. When you start a new analysis, it's good to put the analysis in its own folder within the drive that you're working on, and give it a sensible name like Scottish baby names. Okay. Now this is going to be my working directory. So I'm going to put all my data in here. I'm going to put all my scripts in here. Everything's going to be contained in that one directory. I don't want my files scattered across my file system. I want them all in one place so that if I need to send that to someone, I can just make a zip archive of it. And when I need to read the data in my script, the script will know where to look. It'll look in the same folder. So the first thing I need to do is I'm going to open that folder. I'm going to copy the CSV file into that folder. Okay, so now that CSV file is in that folder. Okay, and then I want to load in the file. Now, the function that I'm going to use to load in the file is called read_CSV. Okay, I just typed that as a comment. I actually didn't type that as a command, just so you can see the name of that function. Now that function read_CSV is part of an add-on package to R. It's not part of base R, but you have to actually install that package if you want to use it. And that add-on package is called readr. Okay? So we're going to install that add-on package first. Now we're not going to install it in our script because it's like when you install an app on your smartphone, right? If you want to install Facebook, you install it once. You don't have to install Facebook every time you want to use Facebook. You just install it once and then it will live on your phone forever. Likewise, if we install, we can go down here, we're going to use install packages. Now notice when I start typing a command in the console, RStudio is smart. It actually starts to try to figure out what it is that I want to type, and it will pop up some suggestions. The function that I want here is install packages, so I can just click on that and it will complete the rest of the command. And notice another thing that just happened. Once I selected the function that I want to use, it pops up this really useful tooltip that gives me information about the command syntax. Right? So a function, right, has a name and it has arguments that you put inside these brackets. And the first argument to this function is packages, which is the name of the package I want to install. In this case, the package I want to install is called readr. Okay? So if I just type that on the command line, I press return, you'll see a bunch of things happen. This is just R installing the package. So right now it's compiling some C++ code, which takes a little time, hopefully not too long. Okay, we'll just wait for that to finish. We get some red text, which we'll just ignore. We'll just keep waiting. Still compiling. Okay, I think we're getting close now. Okay, we'll just keep waiting till it finishes. I should probably have some background music for this part. Still going. Okay. All right. There's a lot of garbage printed out to the console there, which would make sense if you were an R programmer. But all we care about is that this one line, done. Package installed successfully. Okay? So everything worked. So readr is now installed in our system. We never have to go through that installation process again. Right. How do we access the functionality of readr? Well, we need to tell the console that we're going to want to use its functionality. So we use this statement called library. Okay? Now I started typing library. It already kind of knows what I'm going to do next. So I press tab to complete the command. And then I type the name of the add-on package, library readr. Okay? That's what I'm going to load. If I put my cursor on there and press Control Enter, you can see it sends that to the console. Anytime you load in an add-on package for an analysis, it makes sense to put that call to library at the very top of your script. That'll be the first thing that someone sees when they open your script, so they know that if they don't have those packages, they need to install them. Okay, so that's the first thing we need. Now what we want to do is we want to load in the data. Now that we've installed readr, and we've told the R console that we want to access the functionality of readr, we can use this function read_CSV. This is the function that we want, read_CSV, and you can see the arguments for read CSV. The first argument is file. So we're going to type the name of the file that we want to load. Now there's one issue already, okay? Which is if we click on the files menu down here, the babynames file is not there. That's because right now there's a working directory for our session and it is pointing to the wrong directory. We want our working directory for this analysis to point to the directory, the folder that we just created that has the CSV file. So we need to change our working directory, and then the way we do that is we go into the session menu and we go to set working directory and we can type choose directory. And this will give us a file picker. We can go back to my R stuff, Scottish baby names, and we're going to select that and click open. You can see that what it did when we did that is it ran a command on the console that changed the directory to the right place. And if we click on files, we can see that our CSV file is there. It's now visible to R. Okay? So that's very important that when you're going to load in a file, you should point your session working directory to the location where that file is. Okay, so now we can go back and type in our read CSV function. Okay, so read CSV, again, we see the tooltip telling us the first argument is the name of the file. I can start typing the name of the file, babies. Now watch what happens. I don't have to type that full name. If I just press the tab, RStudio is smart enough to know it's going to look for any files that will complete that sequence. So I don't have to type in the entire name of the file. I just start typing and I press tab, okay? Now, if I just run this command, it's going to read that in, right? It's going to read that file in, but the problem is it's not going to store it. It's going to read it in, print out the results of the console, and it's going to be gone forever. So we want to store that in a variable, right? So we're going to store the result of read CSV to this variable dat, okay? Now if I press Control Enter on this line, you can see that it has actually read it in. It said parsed with column specification. This is information. It might not make sense to you now, but this tells you how R interpreted each column in the file. It gives us a warning that there was one row that had a parsing failure at the very end of the file. There was this row that said Crown copyright, so it's some like copyright thing in the file that really shouldn't be there. But we won't worry about that now. You can see that created in my environment, it created this object dat, and it says 209,409 observations on 6 variables. And then it has this little icon here. Now, if we want to know, did we read the data incorrectly? So what you can do in RStudio is you can click on this little icon over here that looks like a table. If you click on that, it will actually bring up the table that you just loaded, and you can see it looks like it loaded correctly. So these are all the column names: year of birth, sex, first forename. This is the number of babies born with that forename in that year of that sex. This is the rank of that name for that year. I'm not sure what position is. We can look at the website, it'll tell us what position is. The rank of the name in that year's list, babies of that sex, expressed as a character string. Okay, so not actually very useful. We already have that information as a number here. Right, so we have successfully loaded in the data, and now we can start doing stuff with it. Okay, you're going to be learning eventually about different functions for manipulating data stored in a table. You're going to be learning about what are called one-table verbs for data manipulation. And the main functions that we're going to be using to manipulate the data in this table are stored in a different add-on package, which is called dplyr. We're going to load that package in. So notice I typed in library, bracket dplyr, close bracket, I pressed Control Enter, and it loaded it in. There was some red text here, some warnings about overlapping names, but we'll just ignore those. That's normal that will come up. Okay. If you get an error, you might get an error saying that package is not installed. You have to go through the install process for dplyr. Once again, you only install a package once. If you want to access its functionality within a script and that package exists on your system, all you need is a library function. And you put that function at the very top of your script. So we read in dat. We have this object called dat. We know about its structure, right, because we opened it. We know about the variables in there. What we want to do first is we want to find the top 10 baby names for boys and girls born in 1998. So because I'm assuming that the incoming class will be about 18 years old now in 2016. So they'll probably be born in 1998. Before I go any further, I'm just realizing I haven't actually saved my R script yet. It's still saying it's untitled. I'm going to save it right here. Just click this little floppy disk icon, and I'll give it a name. I'm just going to call it Scottish _ baby names dot capital R. So the capital R is the file extension for an R script. I save that. Okay, so the first thing we want to do, I'm going to put a comment here. Okay, pull out babies born in 1998. Okay, now the function I'm going to use to do this will be filter. So filter dat year, YR, double equal sign, 1998. This double equal sign means when the year is equal to 1998. I'm going to store that in a variable dat98. Okay? Now I can run that. I can look at dat98. You can see we've reduced the data set down to 4,765 babies that were born in that year. Sorry, these aren't babies born in the year. These are 4,765 names that were given babies in that year. If we click on this, we can see what those names are. Okay, Ryan, Jack, Ross, Lewis, Cameron. Those are all the boys' names. You'd have to scroll much further down to find the girls' names. There's some girls' names here. Okay, right. So close that. If we close the data view, it doesn't get rid of the data. It just gets rid of the view. Okay, so we've pulled out the babies born in 1998, but what we want are the top 10. We want the top 10 babies, the top 10 baby names from that year. So how are we going to get the top 10 baby names? Well, they're already ranked, right? There is that variable rank And all we have to do is pull out the baby names where rank is less than or equal to 10. We can add that as criterion in our filter command. Rank. However, there's a problem. I'm just realizing right now, I don't want to put it in here because then I'll get the top 10. I want to get top 10s for boys and girls. So I want to actually group the data by sex. Is that right? Sex. So sex, B is for boy, G is for girl. I want to group it by sex. Now I'm going to use this function in dplyr top n. Actually, I need to sort it by rank. Make sure, we shouldn't just assume that it's already going to be sorted by rank. Actually, let's do this. Actually, then we can filter. Right. Rank less than or equal to 10. Okay, so what we're doing here, this is you're going to learn this syntax later. The important thing is that you realize we're running these three commands in sequence. We're filtering the data, we're getting out the babies born in 1998. We're grouping that resulting data set by sex. So it's piping the result into this function, and then we're going to filter that so that rank is less than or equal to 10. I'm going to run those commands, and then I see that I have 20 observations of 6 variables. So these are the top 10 baby names in 1998. We have, for boys, Ryan, Jack, Ross, Lewis, Cameron, James, Connor, Andrew, Scott, Callum. For girls, we have Chloe, Megan, Rebecca, Amy, Emma, Amy, Caitlin, Lauren, Rachel, Shannon, and Hannah. Okay, so those are the 20 names we're going to be working with. We want to make graphs of their popularity from 1974 to 2015, so we can see which names are getting more popular, which names are getting less popular. You can see how creative your parents were in naming you. Okay, so pull out babies born in 1998, and now what we want to do is we want to pull out those 20 names. Okay, so I'm going to make a new object top 10, which will be an inner join of dat98. Actually, what I'm going to do is select dat98, which I just need sex and first forename are the only fields I need. Sex, first forename. I'm going to join that with dat on, or actually what I'll do is this, I'll do a semi-join. Dat, and I'm going to join it on sex and first forename. Now again, it's not important that you understand what I'm doing right now. The point is just to see how I'm interacting with RStudio. Okay, I did that wrong. I did that in the wrong order. That should go first. I'm going to change that command because I don't like what it did. There we go. I think that should do it. Okay. So now we should have those names. We have all the Ryans for all years, all the Jacks for all years, Rosses for all years, and we have the number of babies born with those names over the years. And that's in this object top 10. Okay? I don't expect you to understand any of this syntax here. You're going to be learning this stuff later in the course. So don't worry about the details now. Now what I want to do, I have the top 10. I want to plot the data, and I'm going to use another function called ggplot2. I'm sorry, add-on package. And ggplot2 makes really pretty graphs. There are also ways to make graphs within base R that doesn't require add-on package ggplot2, but the graphs aren't as nice, and I think it's actually it's a lot easier to interact and to create plots using ggplot2. Okay, so now the next thing is to create our plot. So ggplot is the function I'm going to use. I want to plot the data in top 10. And for the visual aesthetics, for the x-axis, I want year. For the y-axis, I want, let's look at top 10 again. Number of babies born with that name. I want each name to be a different color. First forename. And then I'm going to produce a line graph. Okay, now I want separate plots, so I'm going to use this function called facet wrap sex. Okay, and I hope I've typed all that right. I'm going to run this line and see what happens. Year not found. Okay, I typed that wrong. Why is year not found? I look at top 10. There is no variable called year. It's called year. So we need to type year. And there we go. Pretty cool. The plot appeared over here in a plot viewer. We can see which names are becoming more popular and less popular over time. So 1998 is right about here. Okay. It's kind of hard to distinguish the colors here. So maybe what we should do is just look at the top 5, because the graph is too complicated. So this is a cool thing about doing this as a script. Now I've changed my mind about having the top 10. I think there's too much information here. I want to just have the top 5. So all I have to do is actually change right here, rank is less than or equal to 5. Then I just rerun the script from this point to the end. Or I can actually rerun the entire script if I want, from beginning to end. Right, I can go to code, run region, run all, Control-Alt-R. It runs everything. So now we just have the top 5 names. We can look at the top 5 names. That's a lot clearer, and we can see what's going on. So, yeah, it looks like the popularity of these names peaked around 1998. For boys, it looks like Ryan has been very popular around this time and just before. You have some names that came out of obscurity in the 80s, like Lewis, Cameron. Over here, girls' names, the ever popular Emma, very popular name, has been popular since the 70s. Sadly, none of these names are increasing in popularity, or people are having fewer babies. Can't really tell from this graph. In any case, you can see how easy it was to get the data here. This is all it took, really, to get these two graphs here. We easily change that if we decide, for example, we want babies born in 2010. You can rerun it. Control-Alt-R runs the entire thing. These are babies that were born in 2010. So now we have these names like Ava for girls that are popular. Emily is becoming popular. Jack is becoming less popular. Look at this one here. This is Lewis. Lewis is declining. Okay. Now this is we can do this because this script is reproducible, right? It runs all the actions needed to create this plot from beginning to end. So if we want to tweak it, we just change one of those actions. It's also transparent, right? People can see exactly what you've done. If you created these plots by hand in Excel, you'd have to go in, cut and paste, and hope that you did everything right.